Sorry. Thanks everyone for joining my sessions. For the ones who don't know me, I'm Jan Hendrik. I work for Citrix as a senior sales engineer. Besides that, I have a personal blog, and some of you might be aware of the German virtualization communities. I'm one of the founders of the one in Hanover, which unfortunately, like E2E, can't take place at the moment. So we also had to switch to virtual one, and I would like to just give you information about VC2Go. So keep an eye on that, or there will be another event this year. It's always limited to keep it interactive. So make sure you join on time to get a seat, but the discussions are always really good and valuable. But now let's get to the actual topics itself. So I prepared several areas to have a look at. And the first area I would like to speak about is browser content redirection. Why is browser redirection important for the user experience? Well, it's not only for the user experience, it's also for the resource consumption. So if you take a look at your browser today, the RAM consumption and CPU utilization is quite high. So you have a lot of load in your central data infrastructure. And the more the users are using the browser, the load gets higher. And if you can offload this kind of stuff to the endpoint, it gets better for the user because the endpoint directly displays the website. And on the other hand, you lower the resources necessary on your central appliances. So what happens with browser content redirection is that like the browser is split into two areas. So you have the broader one, which is the user interface, which is still running in the virtual desktop in the VDA like you know it. And you have the viewport area. And this viewport area is switched back to the local device. So for the user, it's totally intransparent, but at the end, it's just an overlay over the browser inside the virtual desktop. So the virtual desktop itself just shows it like it should look. If you plan to implement it, there are a few things you need to consider. So first thing is, how would you like to handle it? The classical one is like server-side render, server-side fetch, so no browser content redirection at all. So the virtual desktop catches the website from the internet, renders it, and sends it to the endpoint with the HTTP protocol. The first step for browser content redirection would be, or the first option is client-side render, server-side fetch. So what does this mean? This VDA still catches the internet from catches website from the internet and forwards it in HTTP to the endpoint. So the endpoint is now the point where the data traffic is rendered. And the other option is client-side render, client-side fetch. So in this point, the virtual desktop tells the endpoint using HTTP only, okay, this is the website the user wants to see, and the endpoint directly fetches the website from the internet and displays it. If you see these design options, they all have different effects. So the server-side render, server-side fetch obviously means you're still having a high CPU RAM impact, and even the network requirements are still on the VDI side. But you have no requirements on the endpoint side. So it's working with all endpoints you can think of, classical. With client-side render, server-side fetch, it changes a little bit because the browser content is rendered on the endpoint, so you have less CPU RAM usage on the VDA. But as the VDA still catches everything, you still have the network impact on the VDA. And this is fixed with the last one, where you completely offload it to the endpoint. But on the other side, you need to keep in mind, you need a browser on the endpoint which supports it. And the endpoint must have direct internet access, which is especially in bigger companies not always the case when they have SIM clients. So the SIM clients are often limited and have no direct internet access. So in that case, the only option to use browser content redirection is to use client-side render and server-side fetch. To give you an example how this looks like, we started a session and just launched a YouTube video. And what you can see is that we have a really limited CPU usage inside the session. All the YouTube video is running in the background. So it's only 3%. If you then look at the endpoint itself, you will notice that there's another process started, which is named HDX Overlay Browser. And this process does all the rendering for the client. So it grabs the stuff and then puts it on. If you think it's just like, okay, I enable it and everything is running fine, no, unfortunately, browser content redirection is not that easy to implement. When you would like to implement it, there are several things you need to consider on the requirement side. So it's only working with Internet Explorer, Chrome, or Edge based on Chromium, so no Firefox at the current stage. The endpoints must be Windows with Receiver 4.10 or newer, or the Workspace app 18.08 or later. Really important, you can't use the Windows 1912 LTSR version because browser content redirection is excluded from that, because it's just too much dynamic development in this browser area to include it properly in an LTSR release. And you have Linux with Receiver 13.9 or 18.8. On Linux, it even continues. So the standard supported way is that besides the browser, on the endpoint on Linux side, you also need a web container. So you need a libwebkit, a GStreamer, a WebKit GTK+. So a lot of small components you need to consider, and they need properly to work together. So which is sometimes or often quite painful if it's not like a thin client delivered from a proper vendor. Interestingly, with the 1912 release of Linux Workspace app, the Chromium embedded framework was integrated. And if you're not too afraid to use an experimental feature, I can just suggest you to use this one because it's much more easy, much more fluently, and running really smoothly inside the first environments I've seen it. There are some points people, on the other hand, even also don't consider. If you're using browser content redirection, you have some limitations like no downloads and no printing. Why? Because if the content of the browser is moved to the endpoint, the downloads and printing stuff has to be handled by the endpoint itself. So if the user now wants to download something, this happens on the endpoint, which is normally not connected to the same stuff like the VDA does. This is the same for printing and other stuff. So if you use browser content redirection, really think about which websites you can redirect. I had an example where a customer wanted to redirect heavy video websites, and it was all fine. And then they picked up a banking website, and this banking website did a really clever trick. Or inside of the banking website, or at the background, they added a video which was running all the time. So it consumed a lot of resources. But the users had to download stuff from that website. They had to do print stuff from that website. So it was not properly possible for them to redirect this. So when you think about browser content redirection to get rid of some resources on your VDA and improve the user experience a little bit, keep in mind that there are limitations, so you can't redirect all of the websites. The next area we would like to look at is our unified communications. Especially with COVID, I've seen a high demand for optimized unified communication solutions, so that the user has the same experience with running a unified communication solutions. And this is not like only Teams, it's like Zooms or Cisco WebEx or anything else. They expect that they have the same experience inside the VDA like they have on the local endpoint. So fluent audio, no delays, no stuttering, perfect video. Luckily, there's a solution from Citrix, which all thin client vendors could use in general. So, but what does it mean? So if you have normally a standard application installed without any optimizations, you have a user connecting using HDX or to the VDA. And the VDA itself speaks with unified communication solutions, either on-prem if it's a custom using still Skype for Business, and I know there are some, or a cloud-based one. And the communications between the users happens between the VDAs. So the secure real-time transport protocol with the audio and video stuff is running from VDA to VDA, and then to the HDX protocol to the user. So you have a lot of delay because the user first needs to connect to the VDAs, and their SRTP connects to the other VDA, and back to the user using HDX. The optimization changes this because then the SRTP traffic is directly running through the endpoints. So for the user now, the behavior is like, or the experience is like a native app on the endpoint, which makes it much more fluently. Inside TechZone, there is a nice table which lists which software already supports this. So if you have a look, it's like not only Teams, it's Cisco and Zoom, Avaya. Not all of them support all the major OSs like Windows, Mac, and Linux. It varies a little bit, but it gives you a good starting point. And you can even consider like not the default one to Teams offload, but also like offloading Zoom or stuff like that. So if you're wondering why there are like several vendors and you haven't noticed that Citrix published something in that area, that's because it's an SDK we provide, and the vendors besides the Teams app develop this stuff on their own with our own framework. So what this framework offers is that we have the VDA on the one side, which does like the classical stuff, signaling, authentication, and there are media virtual channels and call control virtual channels to communicate with the Workspace app. And with the SDK, the vendor can use the application to use these channels to speak with a media engine, which the vendor also needs to create on the endpoint. And this media engine then handles all the traffic from the application itself. So it's running again. So like you know from the Skype for Business optimization in the past, you had to install a VDA component and you had to install a client component. And this is exactly the same. So you have to install a special version of the software on the VDA side and a media engine on the client side, which is also a component of the vendor, like it was with the Skype for Business pack. And then everything works fluently. Let us have a look in more detail about how it looks like in Zoom. So in Zoom, you have on the Windows side, the media engine, which is a Zoom Citrix HGX media plugin. If you install it and then start a Citrix session, you will notice inside your task manager that there's now the Citrix HGX engine 32-bit running as well. And you can't even install the standard Zoom client on the VDA because obviously the Zoom also needs to be aware that it can use the virtual channels to communicate with the client. So you need the Zoom installer VDI. And then you don't get the classical Zoom, you get a Zoom VDI icon. And what I did is we have a special test environment running. And I did some tests with one of my colleagues. Okay, how does it really behave? So how does it really look like? How does it feel to get a better understanding of it? So what we did is we used our workspace to start a WVD session in Europe. So like you know from everywhere else. And you know it's just launching. The connection occurs. So it's nothing special. It's just our Workspace app connected to the Citrix cloud to enumerate the resources. In the backend, we had connected a WVD session. And now you can see that on this WVD, we already have installed Zoom VDI on the left side. So if you start it for the user, it's except of that the icon has a different name, it looks totally the same. So you can join a meeting, you enter the meeting ID like you did it before on every other stuff. You enter your name and you just press join. You enter the meeting password if it's required, then you can enter it. If it's with a waiting room, you need to wait, or you need for the organizer to let you in. And then you're in and you can see Europe is on site. Don't speak about the quality now. We have some delays with a GoToMeet or a GoToWebinar, so it's not perfectly. But what's really interesting, if you have a look at the task manager, you will notice that the Zoom meeting itself only has a low CPU usage, and also the Citrix graphics engine has not a high CPU usage. So if you have a look at the performance in total, you see that it's around 2 or 3%. And both of us used a test user, so Chris and Edgar, and we are running, or we are both connected to the same WVD system. Instead, if you have then a look at the endpoint itself, you see that Zoom here has a much higher CPU load. So next to Camtasia, where we did the recording with to properly catch everything. And to prove that it's Windows 10 version, Windows 10 Enterprise, we also entered the Win 10. So that's it. There's one other option I would like to highlight here, because inside this SDK option, which I just presented, there's one downside from my perspective, because that is that the vendor also needs to provide its own media engine on the endpoint. But if you have a look, or a more deeper look inside our SDK, there's another option for WebRTC applications. And this option is like that we provide an API, a sim JavaScript, and instead of using the IPC to connect to WebRTC inside the application, the vendor can then use our Citrix API with a JavaScript shim injection. And this one then can connect to our already integrated media engine on the endpoint with WebRTC and do all the stuff which we do with Teams. So it's exactly the same. It's exactly the same media engine, not a special one. But this makes it much more easy for the unified communication vendor to maintain it, because it only means that he either needs to deliver a separate VDI version of his application, like Zoom does, or even be a little bit more clever, like Teams does, detect if it's running on a VDA, and then activate this API injection instead of the native WebRTC stuff. So it's really easy for the vendor, and they don't need to care about anything on the endpoint itself. But as we're already talking about Team, of course, I obviously would like to have an in-depth look about Teams itself. So the traffic is the same like with every other applications. The SRTP is running between the VDAs. You have this delay between the users, nothing special. And the optimization does exactly what it does for the other ones. So the SRTP traffic is moved to the endpoint, much more better user experience. What is special about the Teams integration is that it's using the built-in workspace app media engine. So with Skype, you also had to install everything manually. Now it's just install the workspace app, and the media engine is directly available. It's really important that all major platforms are already supported. And in contrast to the past optimizations, like for Skype for Business, where only audio and video was redirected, now also screen sharing is redirected. So it's much more fluently, much more optimized for the user, and it's much better user experience. Let us have a look at the architecture more in detail to get a better understanding how the communication flow with Teams in details works. So in this diagram, you see we have the endpoint, the user device with the workspace app. We have the data center with the virtual delivery agent and the Teams installed, obviously. And of course, we have the Azure with all the Teams backend stuff that is necessary. So what happens is when the user launches Teams, it obviously does the authentication from the VDA directly to Azure. Teams then detects, okay, it's running on a VDA, and calls an integrated Citrix API, which is directly integrated into the Teams application. Thus, it can use this to start or connect with the WebSocket service on the VDA. And this WebSocket service then itself creates a general virtual channel inside the already existing ECA virtual channels to communicate with the workspace app itself. So now we have special communications from the Teams app through the HDX Teams servers, which is the WebSocket service, through a special general virtual channel to the workspace app. And what happens on the workspace app is that this occurs, and the workspace app then starts the new embedded media engine. So if you launch your local task manager, you will see that the HDX-RTC engine then pops up and is running on the endpoint. This means you now have a two-way communication between the Teams application and the media engine on the workspace or integrated into the workspace app. So if now someone calls, we can use this for the WebRTC communications. What's important to know is that signaling, presence, instant messaging, and data collaboration still are happening between the VDA and the error side. So this is not handled by the endpoint, but as soon as it's switching to the audio, video, screen sharing stuff, the endpoint itself does a connection to other team peers or to error if it's a multi-party conference, and it's running directly then on the endpoint. Gives the user much more flexibility and makes it much more easy. There are a few tuning tips. First of all, there's a registry key where you can see if the Teams redirection is optimized or unoptimized, so if it's enabled. And on the Windows endpoint, you have a few performance codec settings you can try to experiment if you're struggling, because like the endpoint is not properly installed to handle newer stuff, or does mix it up when it's handling like H.264 or VP9. So you can play around with it. I mainly suggest it for old endpoints which lack of performance, to give the user even like a kind of smooth experience with less quality compared to good quality with bad experience. Important to enable it, you need to enable this Microsoft Teams redirections policy inside the Citrix settings. Otherwise, you won't have a chance to get it running at all. So it doesn't matter what you install, it's not working. You need to enable this, otherwise it's not going to work. And there's a few of you might know, I'm often active in the GPU area, so I wanted to add a slide or a few slides about the GPU stuff itself. So what we did is we did some simulated performance tests to just compare what happens inside an environment when there's a GPU present or when there's no GPU present. So for the simulated testing, we use the login VSI workload or multimedia, because for me this is more like the office workload. So I have an office workload, but this is more for me like a not familiar workload, because most users are now watching videos, streaming stuff like that with all that stuff. We had a virtual apps VM with 4 vCPUs, 16 gigs of RAM, and 15 users connecting. And we compared 3 types. So we had an NVIDIA graphics card with 1 gig of frame buffer, 8 gigs of frame buffer, and no frame buffer at all. And we repeated every test 3 times to make sure there's no one-time exception. So let us first have a look what happens if we run without a GPU. So you can see the CPU is quite stressed. We get up to 15 users at that end. It's a little bit more in this diagram above 20, because you have this idle sessions, the admin sessions, the local console session, and all that stuff, which is count towards the sessions, but it had been 15 actual users. But what's also really visible is the RAM usage is quite okay. It's a little bit more than 60%, so far away from being fully saturated. So RAM is not an issue in this environment. But you can see that there are a lot of long spikes. And when you have these long spikes, the CPU starts to queue. And when it's starting to queue, the user gets a delay, or the application says not responding, or it's waiting. And then the user say, there was something not properly working, and doesn't like the environment any longer, and gets more and more unhappy about it. So the interesting point is, what happens if we now add a GPU with 1 gig of frame buffer? And what we notice is there's like a lot of happening much more, but it doesn't really look properly, because we still have the 15 users. But if we have a look at the frame buffer or the GPU, we notice that we already, with a few users, it's fully saturated. So what does it mean when our frame buffer is fully saturated for a GPU? When a GPU reaches 90–95% frame buffer saturation, it starts to swap its frame buffer to the normal system memory. And this means it's also generating more CPU load, because it requires the CPU to put this into the system memory or give it back when it's required again. And we said, okay, we want to optimize it for the user and don't want to generate further stress for the CPU itself by putting some more stuff on it. On the other side, we see that even the GPU is starting to spike to nearly 100% regularly. So it's not really looking optimal. So we repeated this test with a 8 gig profile, and you see it's looking much more relaxed. So like before, the RAM just goes up, the frame buffer goes up, there's no GPU spiking, and the CPU already looks much more relaxed. We still have some spikes, but not as much as we had in the past. So it's much more easy and much more helpful to do it like that way. If we directly compare it to you, we'll even notice the difference. So on the left side, so the environment was always the same. On the left side, the frame buffer is always fully used, and even the GPU has a higher load. So too much load on this. Just to give you a real life example, I just had our customer complained that his users are regularly struggling with performance issues, and he monitored everything. And then I said, okay, let's have a look. And it was a virtual apps environment with an M60 connected, and there was only this one M60 connected. But what they did is they put 40 users on this one system, and what happened is that their frame buffer loss running like flat, like the line above we see here, because it was always fully saturated. And this had the effect that regularly, in some circumstances, the users noticed that there are really performance issues. So sometimes it was working properly, and other times they are really struggling with it. And then they spawn up mirror so that the frame buffer wasn't fully saturated any longer, and it got much more better for them. That's why it's really important to have a look at the frame buffer, which is often forgotten by the people inside of this stuff. But I started that we wanted to compare the no GPU and the GPU stuff. So we have here now the direct comparison, and I think it's really obvious that you see that on the right hand we still have a lot of spikes, but the CPU is much more active and not like running at full load. So for the user, the performance gets much better at this area, and just because of adding a CPU. On the other hand, you might notice that there's a slightly little bit more RAM usage, but not really noticeable. And we are still on the same level at the end, around 70%. We still have RAM left, and this shouldn't be the issue. The point is, if you then get into the stuff, you also need to speak about HC's configuration policies. And if you have a look at all the policies available, there are 4 main ones which are really effective, or which are really controlling the behavior inside a GPU-enabled environment. So it's visual quality, it's use video codec for compression, it's optimized for video graphics, and it's a low visual lossless compression. What is really, really important is that you need to always check all of them because they are related, or sometimes one disables another. So if you say, for example, visual quality to setting build to lossless, you can just get rid of optimize for 3D graphics workload for 3D graphics and use video codec for compression, because they are completely ignored. So it doesn't make any sense to have a look at them. As there are always people confused what happens when, we have a few nice diagrams to explain this a little bit more in detail. So what happens when? So we start with the policy use video codec for compression and configure it to further entire screen or use when preferred. Next to that, we also enable the optimize for 3D graphics workload. So these 2 settings are clear. Next setting we configure is the visual quality. So inside visual quality, we then select always lossless. We will result in in full screen H264 444 if the client supports 444. If the client does not support 444, and of course visual lossless must be enabled for that, will end in lossless. One is encoding, so include lossless, pixel perfect, but not with H.264, instead with JPEG and stuff like that. If we set to visual quality to visual lossless and also enable visual lossless, the policy visually lossless, and the client still supports 444, we end in H.264 444 with visual lossless. If the client does not support 444, and we have 718 plus version of the VDA, and the client supports selective H.264, we end in H.264 420 and we RLE build to lossless. If the client does not support selective H.264, so if you have like an old SYN client or an old, really old workspace app or a receiver version, we end in JPEG. Last setting with visual quality is low, medium, high. Interestingly, it doesn't matter if you select low, medium, or high with the other settings in combination, because it always ends in full screen H.264 with 420. So when you set use video codec for compression for the entire screen and use run preferred, you can visual quality low, medium, high, always the same result for the user, which is also confusing for many admins because they are not aware of that. So let's change the setting a little bit and keep proactively changing regions or use when preferred, but disable optimize for 3D graphics workload. So again, we have the visual quality policy, which does our first decision what happens. If you select it to always lossless, we end up with lossless RLE. If you select build to lossless, and it's 718 and the client supports selective H.264, it's like before H.264 420 and RLE 12. If the client does not support selective H.264, we end up with JPEG and build to lossless. If we now select low, medium, or high, it has an effect because at the end, the result displays some areas in JPEG or with JPEG. And this depends if the client supports selective H.264, because then some areas are also displayed with H.264, like moving images and stuff like that. If not, we only fall back to JPEG and RLE. For then, I have a more easy example. So if we then change the use video codec for compression to do not use, and the visual quality to always lossless, it's lossless RLE. Or if you set it to build to lossless or low, medium, high, it's JPEG and RLE. Another point, which I personally think is quite nice for troubleshooting and seeing what happens or not happens, is if you have a look in PowerShell, that's a VMI object and a Citrix virtual channel SYN-wire possible or option available. And if you have a look at this area or the namespace and list all of the available options, you will see a lot of graphic stuff. And I just want to highlight a few to show you how the policies which are configurable are reflected. So you can see, like we have here the maximum frames per second, which is here the default of 30. If you modify it, it would be a different value at this point. Or you have the video codec color space, which is U420. So it's really good to know, okay, which UF codec is used? Is it U420 or U444? Or is there optimized for 3D workload really enabled, or is it disabled, like here where it is false? Or when is the video or which kind of video codec is used? So in this case, we have use video codec if preferred. So this PowerShell command gives you really good detailed information about the settings which are active, and there are even other ones for other areas. So just a good tip for me, use this to get some better insights into that area. But there are also some policy registry settings, and if you have everything configured by default, the user policies will look like that. So you have under HKey local machine our software policies, the Citrix area, and for the user session you will find the user session number. Obviously, if it's a desktop, there's only one. So the first user has session number 1. And under user graphics policies, you find configured graphics policies for the user. So this one has non-configured, so everything is the default setting. Or if we configure like the most related ones, it gets much more. So we then have 7 graphics policies available: the low visually lossless compression, the target frame rate, the optimized for 3D graphics workload, the target minimum frame rate, the use hardware encoding for video codec, or the use video codec for compression, and the visual quality. And you can directly see the settings of the policies. Most of them are self-explaining, like frames per second. You see here the number of frames that are configured or optimized for 3D workload, which can be just enabled or disabled. So disabled is 0, enabled is 1, or the same use for use hardware encoding for video codec. But there are 2 other ones which have more settings, which are visual quality and use video codec for compression. So visual quality has this 5 settings: always lossless, virtual lossless, high, medium, or low. And depending on the selected setting, it's 0 to 4. And it's the same for use video codec, which has 4 settings: for the entire screen, do not use, use when preferred, for actively changing regions, which is 0 to 3. What's even more important to know is that, or many of you are aware that there are tools which can change these settings on the fly. On the other hand, you can do that yourself inside the registry and change these settings. So you can modify something during the session to test another setting and see what happens, or if it's working or not working. And that's it. Any direct questions? Okay, perfect.
Just 1
Thanks
second.
for your time. And
yeah, just 1 second. There are a couple of questions. Yes, 1 second. So the first question is, does browser redirection have prerequisites via ADC NetScaler HDX support? My customer has F5. Did you got the question? I am gonna forward it to you so that you can see it yourself. So the question is, does browser redirection has prerequisites? Like, for example, NetScaler ADC or HDX support? He's asking that because he has an F5.
So the important points are that you need the corresponding workspace app which supports it. And then it depends a little bit on the mode you choose. So if you select client fetch and client render, the client obviously needs direct internet connections. But besides that, it doesn't matter if it's passed through F5 or NetScaler or so.
All right, okay. The next question is, there is a way to monitoring Teams with HDX monitor with a registry key value. Does this work with the other tools like WebEx, Jab, or Zoom as well?
No, because for the other tools, you have no central policy to enable it. The difference for Teams to the other tools is that, for Teams, everything is natively integrated into the VDA and on the client side. And the other tools need special editions or versions which you need to install to get it enabled.
All right, and the last question so far is any recommendations about using ad blocker on and location tracking on browser to keep the CPU utilization down?
Not that I'm aware of, because ad blocker restricts the application itself. What is more interesting is like with VAM, the general system optimizations, but not for that special part. And the ad blocker restricts the application at all, so I don't see a value in combining that, because then the user can't work any longer.
Okay, so let's take the questions to the Discord. If anyone has any more questions, please ask those in Discord, and I'm sure that Jan will be more than happy to answer them. On this note, Jan, thanks very much, and was a great session, a lot of information. Thanks very much.
Hope to see you in Hamburg.